Good morning, everybody. So I'm going to talk today about semantics-based summarization of entities in knowledge graphs. And my advisors are here, Professor Amit Chet and Krishna Prasad Tirunaya, and Professor K.K. Chen is also here. And remotely joining Professor Gong Cheng from Nanjing University, China, and Dr. Edward Curry from National University of Ireland, Galway, Ireland, and Dr. Hamid Motahari from IBM Research, USA. So for them it's not morning, some of them it's night, for Gong it's midnight, and then for Hamid it's early morning, and for Ed it's afternoon. So, but I'll say good morning. So let's start. So this will be the talk outline today. So I'll be giving a brief introduction and then touch upon three topics along the way. So basically talking about knowledge, so what are triples? So we represent knowledge using triples. So this is an example in the schema level, and this we call them subject, predicate, and object. And then we have a data level, that means this is the schema level, this is the data level. So we have two levels basically, and then we represent them in triples, and this is an example that we encode in RDF. And then we look at data sets available today on the web. So we see linked open data cloud, so they are openly accessible. So this is the state of it in 2007 and 2010, 2014 and 2017. So it has grown significantly and constantly. So we have this much knowledge openly accessible, and there are many other data sets which do not belong to this graph, but they are also available on the web. So this is community generated, and we also have now companies started generating their own knowledge graph for proprietary purposes, or to support, facilitate their applications. So we see Google, Bing, Yahoo, Amazon, they are popular ones. So it's becoming popular that they want a way of encoding knowledge. So we see it's getting popular, and then knowledge representation becomes available for most of the people. And since we have that much knowledge, we need a way of summarizing. So basically we call an entity a real world thing. We represent that entity detail using property and value. We call them a feature. I'll explain later the notions. So this is a sample description of that entity. So these entities make up the knowledge graphs and datasets that we have seen earlier. So there are millions of entities and billions of facts in the form of triples. And then because we have that much knowledge, we need a way of summarization, and it could be useful for quick understanding of or presenting user needs, or supporting specific tasks like entity linking or disambiguation. So people have been developing techniques for that. But this is not a recently appeared technique or method that people were talking about or supporting. So for example, Thales rich media reference that we got to know in early 2000s. Dr. Seth is part of that creating this ecosystem or the framework. Basically they had an ontology and also a data layer extracted from the text on the web. So this is, these are examples how summary or concise representation of facts coming from the knowledge graph at that time. And now, these days, we encounter this knowledge enabled search or entity-centric search. I search something related to entity, for example, here it's Marie Curie. So Google presents me or anybody who searches using a snippet taken from their knowledge graph. So this is today built for large scale. And the earlier slide we looked at how it started, or people started talking about it. And in today's talk, I'll be focusing on mainly two aspects. The first part is about single entity summarization, and the last part I'll be talking about multiple entity summarization. So these are specific components that those systems have. Basically, I use lexical knowledge and schema knowledge to come up with methods or techniques in solving these problems. So specifically, my thesis statement, I can put it as entity-related structured data on the web can be concisely and comprehensively summarized. Comprehensively we mean it will be diversified. So in achieving those characteristics, we use this technique, so we conceptually group and rank and also enrich further the structured knowledge, and we handle the relatedness of multiple entities. So we look in detail how we achieved these specific components or methods. So first, let's go into diversified entity summarization. This part is about, we talk about single entity summarization. So looking at the existing system, so we could see people have been proposing methods using, for example, different ranking mechanisms, page rank, random cipher, variants of them, and informativeness, frequency, different kinds of them. But the problem is, you see the example here. So let's say this is a sample of facts for an entity, actually for Marie Curie. But if you rank and then let's say pick the top 3 from these 4 facts, they tend to be more related to each other. So given the conciseness of entity summaries, if you only do the ranking, we may be missing something. So what we are missing is the coverage or comprehensiveness. So we, instead of only doing ranking, we do grouping as well. So this work is published in AAA 2015. So by grouping, we achieve diversity. That is our goal here. So let's look at an example and then try to understand what we are doing here. So take the example Marie Curie. So this subset of facts we take from DBpedia knowledge graph. So we see some facts for this entity, but what we do here is we try to group them into different groups. So we call them facets. So different colored facts belong to different groups. So here are some notions. So we call a property and value as a feature, and then these features belong to different facets. Facet means simply a group. So we have different groups. What we do is like we have a way of grouping things now, and then we also do the ranking. And these numbers represent how they are ranked in each group or facet. And we look at an example. The first one we call it concise and comprehensive. In other words, it's diverse, because the facts F1, F2, and F6 selected from this set of facts coming from 3 different groups. So given the length of the summary of 3, we can provide a more comprehensive entity summary. So that's our goal.
So have you seen an environment where there is an express constraint into the amount of metadata you can present in the summary?
You mean there is always a constraint?
So, whether you present 3 of those properties or 10, right? Depends on some choice somebody makes. Have you seen any discussion where people, based on HCI or some other characteristics saying, this is what human typically like to see in terms of, so in Google's, let's say, info box, how much should they present? Have you seen any idea as to amount of information you can present, right?
Yeah, you mean the, let's say, number of features to represent? I haven't seen specific studies or saying this is relevant, but it's also application specific. So let's say web search, it may be different, or let's say you use the entity summaries for entry linking. Specific users like to see more, we can always give them more. But I haven't seen specifically this is the right number.
So in your evaluation, how did you decide how much to present to your evaluators and say, tell me whether it is comprehensive or tell me that it's too much?
So we didn't evaluate whether we are giving them too much information or less information. We decided on a threshold. Let's say we did like 5 length summary and 10 length summary, and we simply picked it without like going into further analysis whether this set of users liked 5 length summaries. But we presented them what we were interested in, like considering it a summary, how much they like the characteristic of the summary. So we did measure what is the length that they would like to have.
Mm-hmm. No, but if you step back a little bit, right, the number of triples associated with each entity runs into, let's say, 100.
Oh.
And so anything that reduces the number of triples by an order is what you were shooting for.
Yeah.
And you compared it with the other state-of-the-art techniques.
Yeah. In our evaluations, we were setting the length consistent for all the systems. We randomly picked. So this is a summary you get. You rank based on the characteristics you like. So it's a good suggestion that it can be further like extended study, or somebody can do like present way like this is the amount considering the length of the entity description. So you should be certain, let's say 10% or 5%.
I mean, so let's suppose I'm using this summarization to help people make the decision about e-commerce. Somebody is browsing something in a store, and now you have an opportunity to say a little bit more about that entity, such that that person has better appreciation of what and gets probably more incentivized to purchase that item or get that service. So there will be a lot of issues that can come into picture in terms of, for example, things I'll make most money on versus things where other people have, when I present this information, other people have, taken the bite, that kind of stuff.
Yeah, what I've seen also is like, let's say we see Google and Bing, we search, their summary length is more or less constant. They don't change according to the entity. So they decide themselves, this is the length that we are going to present you.
Right, but they also, so you have possibility of choosing the amount of, the coverage in the summary based on the content itself, based on the potential application, and so there are plenty of other things that can be looked at, right?
Yeah, and also personality aspect, we don't go in detail here. So people have been analyzing query logs in selecting the facts from the knowledge graph. I heard Microsoft has been doing it recently, maybe Google. So they analyze the search behavior for each user and then produce the summary. Let's say this fact here, a user searched something related to, let's say, computers these days, and then the entity description has something related to it. They try to provide you related facts using query logs. But we don't go into that detail.
Actually, you can connect up your third part by saying that you can potentially bias your summary based on other entities, and that's exactly what you've done.
Yeah. So we're taking bit of the context into summarizing.
I think TK makes a very good point that I didn't see that yet done. Is that here are a possible context of need for summaries, and in this case, there's this additional thing that would give you the context, and for that you could use this multiple. So I'm providing you the platform for building that kind of solution.
Yeah, and we look into detail the last part. Still, it could be improved, like taking actual text input. We only process the knowledge graph, the knowledge part. We can also take the input from actual text, analyzing using NLP techniques, further extend or modify the techniques. So, in solving or coming back, we want to group things as I've shown here. So, what are the challenges, or why it's hard? It's going to be hard, or it's easy? Because for each entity, the number of groups change from entity to entity. For example, for an actor to President of the United States, to a movie, to a building or a country, the different ways of representing knowledge is causing it to have different number of groups. So we, for example, also we want to have connected somehow the semantic relatedness of fact. So for example, take these two features from entity Marie Curie. So one is talking about her field chemistry, other is about her alma mater. So if you analyze them syntactically, they are different. Their characters and words are not the same. But then we want them to be put together. And that's the challenge that we want to solve. So in solving this problem, we adapted a hierarchical, incremental and conceptual clustering approach called COBWEB, which is quite old in the literature. But we find it interesting and suits our needs here. So there is another challenge that we face because we process triples and then we extract features from the triples. For example, take this feature, birthplace Honolulu. So the clustering approach that we use, for example, COBWEB, uses attribute value pairs. So more attribute value pairs items has that we need to group, they will have better clustering quality. So for example, here birthplace Honolulu reflecting a fact from Barack Obama. So if I say different colors show you the attribute and value. So the property is the attribute, value is birthplace, the other is value, is the attribute, value of the value is Honolulu. So we have only two attribute value pairs. So how, then it won't give us the semantical relatedness in our grouping. So how we can improve? We use an expansion technique. So I'll briefly explain how we do it. For example, for a property birthplace, we take the label and we pre-process it and expand it to have a word set. We take the hypernyms from a lexical database. So for example, we use the word name. Hypernyms means the abstract terms. So we have representative word set for the property label. So we do the same thing for the value, object part of the triple. For example, here Honolulu, but instead of taking its label, we take its type associated in the ontology. So for example, it's a place. So we expand it using WordNet and then we get this word set. So we extend property and then value and then combine both of them, make the union and then create a one word set to represent the feature. So here are some examples. We can see we always start with attribute value pairs, two attribute value pairs for features, and we expand each property and value and we end up having this word set. So it's a representation of the earlier feature to work in our algorithm, so the modified approach. So how is it going to effectively do? Let's look at example or try to understand what is it effectively doing. So this scenario is considering without any expansion. So new item comes and these two items already exist. The orange color one and the green color one already exist in the hierarchy or the dendrogram. New item comes, we cannot see, or the algorithm cannot see any overlap or similarity. They are syntactically different and also but semantically similar. But then our representation doesn't convey the idea. So it comes and then it will make three groups. But our objective is to put birthplace Honolulu and region Illinois in the same group because they are related. But Vice President Joe Biden is not related as these two together. So how it works is like this. So new item comes, we have the expansion. So these are the groups that already exist in the hierarchy. And these items are expanded already. And the new item comes and we could see the relatedness of the expanded features. So there is overlap between these two, but there is no overlap between this and this group. So it won't be grouped together. So semantically, we achieve what we intended to do. So this new item will be grouped with the leftmost group. So that's how the expansion mechanism is working inside our grouping approach. Now we have a way of grouping, and we also need to rank features for each entity in the facets. So there are two ways we can look at the values of the features and then the property and value together. So the intuition here is, if I give you or a user this in the general purpose sense, New York and Beaver Creek. Beaver Creek is local city and New York is popular and everybody tends to know it. And they would prefer seeing New York because it will be more recognizable, or the entity will be recognized having New York as the value instead of Beaver Creek. And then if you see property and value together feature, if I say somebody works in Washington DC and then somebody resides in White House, I would know if I pick this one, somebody might guess I'm talking about Barack Obama. So we should be trying to get this kind of facts instead of the other one. So it needs to be more informative, but the value itself could be popular. So we want to get a balance between these two. So what we do is like we adapt or maybe make use of the TF-IDF based ranking. So these are formal equations that we measure the statistics of the triples. Informativeness effectively the IDF part. So we count the number of features in the knowledge graph, and then the popularity is just the frequency of the value of the feature, and then we multiply them together, take the product, and that we call the rank, which is effectively the TF-IDF. What we do for, we adapt it for triples, and then putting all the things together, what's happening is like we get the feature set, we enrich the features by, we use here semantic expansion, we see that word set creation, and then we do the clustering using cobweb algorithm, and then we do the ranking influenced by TF-IDF mechanism, and then we create the facet identity summary. Going through each facet, pick one by one from each facet, it creates a facet identity summary. So for the evaluation, we created a gold standard using 15 judges. We gave them the set of entities and asked them what is the entity that you prefer to see, and then they select a set of entities of length 5 and 10. And we measure the agreement between the human generated entity summaries and the average overlap between the computer generated one and all the human generated entity summaries. So it is the quality, we call it the quality of the summarization. So the results we evaluated against state-of-the-art approaches. Raylene and Summarum are existing approaches that do entity summarization. For this, we use DBpedia knowledge graph. So for the summary quality, in our gold standard, we achieved higher results. Basically, because we were able to cover more facts given the conciseness of the size of the entity summary. So,
what was the first work in this whole line of work?
FACES is our approach. FACES is the name. Facet identity summaries is the approach that we are proposing here.
No, Raylene is the first one.
For Raylene is
which uses page rank.
It is based on page rank. It's Gong's approach proposed in 2011. And Summarum is another one. It's a variation of page rank again. So both of them considering ranking mechanism.
So the overlap is based on terms, or
let's say I create. I'll show this example.
Yeah,
let's say this is computer generated summary examples. So let's say this is our system summary, and then let's say we have similar summaries created by 15 different human judges, and then we measure the overlap between this one and all the 15 others for this entity summary. And we take the average.
Overlap based on what? Is it terms?
Existence of both features, property value together. Not only the value, but the summary should be exactly matching
property
the feature.
and the value.
So the judge should have picked birthplace as one of the relevant properties in summarization.
Yeah, and he should also pick that specific place, not only the entity. You can measure only the property, but we measure actual feature. I mean the item.
No, maybe I should clarify that. So when we ask different people to summarize, right, we could not find one consistent summary across people. So what we did was we took the generated summary and overlapped it with various summaries that people generated. And in the process, we said that our does a better overlap than the others. Because we couldn't pick one, we had to somehow make use of multiple summaries to evaluate how best we can address multiple needs.
Yeah, to be fair, so instead of
exactly to that point, meaning that Kalpa, did you basically fix the number of groups that the summary could be presented in, and then measure the overlap? Because otherwise, you would imagine that different people or different systems will come up maybe semantically the same set of groups, but differently represented, right?
You mean in our grouping or
No, for example, I think did the 15 judges have the same set of
No, 15 were
types all to be picked from?
Yeah, we gave them all the entity descriptions. Not everybody, 15 people created all the 50 entities. We distributed them, let's say 20 to 25 entities for each person. But at least one entity received around 5 to 7 different summaries. So that's why we are making the average overlap.
No, so answer to Hamid's question is that we did not tell them anything about grouping.
No.
Grouping is our way of getting to the
diversity.
Summary.
Yeah. We didn't tell them. We didn't even tell them which summary generates. Even in creating the entity summaries, they don't have that information because they are generating the gold standard. But for the second evaluation, user preference, so we asked users how they like these three systems. It is a blinded evaluation. We didn't tell them which system generated which summary.
So in that case, the input attributes to both groups, both humans and machine, were the same.
Yeah.
Because I would imagine that if not, the eventual summaries will be completely different, right?
Yeah, they are the same because we take the features from the knowledge graph, DBpedia. We input the same thing for the humans, same thing to the machine. And then for all the three systems, the set of features were the same.
Kalpa, just a question on the judges. Was there much consensus on the summaries for the entities?
Yeah, that's what we were making. We were making the last row of the table average agreement. So average is low. It's understandable because the number of features, on average we had 44 features to pick for 5 length and 10 length summaries. I remember sometimes the length of the description went about 150 features. So picking 5 from 150 features, it's unlikely that everybody is going to agree on the same thing. So the average overlap is a bit low, considering that the number of features per entity was a bit higher in this case, in this evaluation.
What do you think that means when it comes to summaries in general?
The idea is it is hard to generate a summary that satisfies all needs. We also need to take into consideration maybe for each person and then what they like.
So in that case, can you go back to your definition of average quality? How do you define the quality? If the overlap is low, it's basically the machine and different groups or different algorithms. How do you abstract that into your quality definition?
So the average for the agreement is the first equation. So we have so we are measuring only the average overlap between only human generated summaries, not with the computer generated one. So we are measuring how much the overlap between judges that we have.
Okay.
But then the quality is between the computer generated one and all the human generated ones for that entity. For each entity we measure the quality and then take the average.
Kalpa, who were the judges?
So we had, they have reasonable knowledge on, many of them had understanding of the knowledge representation, because it is on triple level, we gave them the features. They were at least graduate level students or professionals.
And the entities you gave them, were they?
Well, they were random.
They were random. Were they limited to anything like location or place
Yeah.
or person, or were they totally random?
The type of the features we picked based on popularity of the concepts. I think we picked from actors, politicians, movies, countries, places. I remember. We didn't pick entities like people have less idea of knowing. So the types we restricted it to be popular, that people may understand at least what we are talking about.
And did you look at understanding the level of agreement between judges?
Yeah,
The entities were of the same type. So, for example, if the judges were both describing an entity of person, did you look at the agreement when they talked about a person summary versus a location summary?
No, we didn't measure for type specific. It was on average for all the types for this year, for this gold standard.
Okay.
And for evaluation of the other basically approaches, Raylene and Samaram, did you basically implement them, or
So,
how did you measure
for
using?
Raylene and Raylene M are variation which slightly modified the Raylene to be Raylene M to handle the diversity on syntactic level. So Raylene M, Raylene I got the code. It was implementation of Gong, Dr. Gong Cheng. And Samaram, at that time we had the online service to get the facts, summaries. So for Samaram, that's why I could measure the time for running that system. So we got the summaries from the online service, REST service.
Maybe let me try to summarize exactly what our evaluation criteria was. So rather than make anybody to generate any particular summary or make any one particular person happy, what we tried to do was to minimize dissatisfaction across the board. I mean, that's how you did the evaluation, right? Because you tried to find the overlap and do that.
Yeah, so the fact that I was telling earlier to Dr. Shet about taking the personalization into this work, so we didn't consider that part. So we are generating summaries in general. So we weren't analyzing each user query logs before or their personal preference or using browsing history. We didn't do those things.
So the summary answer here is just the feature value.
Yes.
Okay.
Similar to what we get in Google search.
Okay.
But maybe they are getting our preference. So, but we were not doing that part. Personalization.
For evaluation 2, so the average agreement are missing. I mean, still there's some agreement, right?
Yeah, I mean, for the evaluation 2 is about, first study we only did Faces and Raylene, and then the second study we did all 3 systems.
I mean, you still use multiple judges, right?
No,
No.
we had like 69 judges. For that, we weren't creating a gold standard. We just gave them blinded results for 3 systems and asked them which one you like better. Give your ranking. This one is better. Faces is better. Give one. Second is this, and third is this.
I mean, what's the agreement between the users ranking?
So I just measured their preference, the percentage. So let's say out of 100, 54 of them liked Faces, 16 of them liked Raylene, 30 of them liked Samaram. So for example, this is what we did. We gave, for example, for one entity, we gave them these 3 summaries. We didn't mention the names. We asked them, what do you like in the order. So overall, by average, these are the percentages that the numbers they liked over the others.
This is not
Did you also?
Go ahead.
Did you also look at the sort of amount of information in the summary and diversity of the summary, or Basically, if the summary comes up with only one group versus 10 groups, does it make a difference in the quality of the summary?
It makes a difference because it's not alone making a difference. We do both ranking and grouping, so it's a combination of both. We haven't presented the grouping approach as a standalone contribution, which we could, and anybody could extend and make it even work more better than we use here. There could be further improvements as well, I see in my experience. Because we do the semantic expansion, there are sometimes noise which makes the grouping not so good. So there could be improvements made for the groupings as well. But we didn't evaluate on that specific aspect. Our goal was to make diversified entity summaries, but that could be done. It could be a significant contribution as well.
Thank you.
So the number of facets for each example should change, right?
Yeah, number of summary length is the same.
Summary length is the same, but actual facets depends on the
Yeah,
clusters,
depends on
right?
it because it's a hierarchical algorithm. The numbers can change, different groups. Number of groups change.
Yeah,
We are not fixing. Give me always
but
5.
there are some optimal number of groups. You just cut
Yeah.
the hierarchy.
The level that we cut was determined using empirically. Like we looked at many examples, and we thought cutting at this level the dendrogram is.
Okay. So what if the optimal number of facets is less than 5, for example? How do you?
So we
you
are
just-
going in a round robin fashion. We do enhancement for this in our second approach. We also rank facets, which we don't do here. Picking from the facets is random here.
Yeah. I mean the total. There
We pick more than one from one facet in that case.
Okay.
If the summary length is higher than the number of groups, we pick more than one from a facet. We don't know which facet it is. But in the second step, we do rank the groupings, facets, then we know the highest one gets the priority in picking more than one.
Okay.
So let's move in to the second part. So what we looked at the summarization on the first part that we looked at is about summarizing entities with descriptions that have object properties. I'll explain what is object property, and they are typed in the knowledge graph with an ontology, and then we could expand the features and then get the better clustering. But the literals, they don't have typing, and then we couldn't use our approach. So what we are doing here is, for example, taking DBpedia, we have this much data type properties and this 1103 object properties as of the current version. So number of data type properties are not less, they are comparable. Even though some of them are noise and then labeling properties, but then they are compatible. So for example, this property in DBpedia location, it is a data type property. That means the value of it is a literal, a string. For example, California, Dayton, United States, all of them are strings. They could have been typed. Assigning class from the ontology, for example, as a country or a place, which is not happening. So because of that, we cannot use it in our clustering, and also maybe other applications may not be able to use it for data integration, for example, and alignment, because we don't get anything semantic here. And by assigning type for these properties, we take a use case as a entity summarization and show that it is useful here. So looking at this, so Barack Obama in DBpedia is typed as a person or a politician. But Michelle Obama, in one of the features, not all of them, is mentioned as a literal. And it only has the type saying string, because a string cannot be an entity in knowledge representation. Because of that, we don't have the entity typing. We can't use our grouping effectively, so we can't use our phases approach. So what we do here is we give a way of typing these literals and also show that after we type, we could use them in the entity summarization. So what are the challenges? That is it simply always one option that we get to type? Take this example, like 44th President of the United States, which refer to Barack Obama. So the different colors represent different options that we can pick to represent the type. Is it talking about the president, or is it talking about United States, which is the country, or entire phrase altogether? So which option we should pick, or which is the correct type? If you pick the type as country for this, it's incorrect because it's talking about the president, who is a person. So looking at comprehensive example, how this kind of an approach can help machines and also maybe humans to look at details more semantically. So we take a triple here. The property is object property, which means the value, the object part is an entity, and it is typed as a politician. We take another triple and its value is a string. It doesn't have anything beyond the implementation type string. Another triple, it says the governor of Massachusetts, and it's also a string. And we apply an approach like ours, and we say the second triple, the literal speaks about a president, and the last one talks about the governor, and then these are classes in the ontology. And the ontology hierarchy, it says they are subclass of politician. Now we could see the link between the first triple and then the last two triples using the ontology class, because all of them talking about a politician or a person. So this is how it could help machines or humans to infer more knowledge or make the processing easier or effective for some applications. So here are some techniques that we use. Input literal comes, we do pre-processing, and then we do some tasks, and then I'll briefly show you the flow, and then we compute types for the literals. So here is the actual flow that we follow. So literal comes, we extract n-grams and focus term, and then it goes through several conditions. In each condition, first it checks whether the focus term, which we identify using natural language processing techniques, focus term detection, and we check whether it directly matches to an ontology class. If it is, then we directly have the type or we have solved our problem. If not, we analyze the n-grams along with the focus term and then try to match to an ontology class. And if not, we try to match it to an entity and then take the type of the entity, and then we get the type of the literal or the phrase. Lastly, what we do is, like, if none of them work, we just get the maximum overlap semantic similarity for ontology class and then type it as of that class. So this is the process flow that we follow.
So did you have any empirical observations on how each of these things help, how much they help? Clearly, priorities of what would be a good match, more useful, more semantic matches are clear. Question is, for the kind of data that you consider, which of these were, contributed to a better understanding of the content?
So the first three checking are more semantically efficient, I could say. For the last one, because we don't have another way of clearly saying. So sometimes it could match to not so correct type, because we use the semantic similarity between the focus term we identified against all the ontology classes. For this we use UMBC similarity index or score. So this is sometimes can be not so correct, but then we try to estimate because if it matches to a directly an ontology class, the focus term, which is the most accurate one, we could say. If you get an entity and its type, it's going to depend on how we type the entity, and effectively we get the type of that entity as a type of the phrase. So I consider these first three parts are more accurate compared to the last processing.
But see if I understood correctly, the match n-gram, focus term, and entity labels, that would happen only if the previous two things already was yes, right?
No, this happens if we didn't get an answer from this part, this processing. If it is no, this is if condition, for example.
So you're expanding each of them just a little bit,
Yeah.
semantically.
Yeah.
And giving away
Expanding
the-
means like if there is a direct match for ontology class, it's the type. If not, we start analyzing n-grams and focus term together. Maybe we are doing a bit more processing. Yeah, that's what happens.
So what was the coverage? I mean, what percentage got done at each level? Any idea? Generally?
No, I didn't measure that much detail.
Because if you got a lot, done in the first one or second,
Yeah.
that's fantastic. That means you have a very semantic system. If you had to go to, the bottom thing, and only 10% of all the entities got typed using the, first three as, decision box you have, then you really have a significant mismatch, or your ontology coverage is, not that much. It's probably not a relevant ontology. Probably there is no existing good ontology to help you type.
And one other observation I noted is that because ontology is mainly developed or getting developed progress based on the entities in the data level. Because if there is a need to type an entity, maybe they'll introduce a class or amend the class hierarchy. But then it's not affected by the literals. And if there is a need that we don't have the correct class in the ontology, nobody is going to add it to the ontology. So in that case, processing the last part, we may also be getting negative hits. Because ontology is not adapted or developed to suit literals or the entities.
But, so for example, ontology itself may be rich enough. For example, let's say class name, they may give synonym. Like say teacher and educator, and now either of them will match.
Yeah.
It's the same general semantic class, but after you're using a label. So the label could have variations, and if the ontology captures all that, then your matches would be higher, right?
Yeah.
So it will depend on. So I'm just trying to get a sense of empirically how each ontologies are there. So whether the ecosystem is there or not.
Yeah. If we miss it here, there is a way of capturing it in this place. Semantic overlap. It will get the highest overlap. Because if, let's say, the literal says, the focus term says the teacher, for example, but the ontology has the educator. It won't match here, but then somehow there is a chance that it gets matched in the last part. So that's why we didn't remove this one. There is a trade-off. If you remove this, there is a less chance of semantic similarity matching. But this further could be improved, I agree. And then for the evaluation, for the type generation, we measure the precision and we measure the mean precision. That means the average precision for all the items that we type. And any mean precision is the ceiling of precision. That means if the algorithm generates at least one correct type, this will reflect that part. Whereas precision counts all correct and negative ones, but any mean precision just takes the Boolean value and then gets the average. So this is the result for type computation. We using DBpedia, taking a sample And the baseline we considered was the DBpedia Spotlight, which detects entities, and then we use those entity types as a type of the literal. So what the evaluation tells us is that if we randomly get the type from entities, or we don't have a proper way of deciding which is the correct type, we won't end up with good results. So that is the takeaway message here. So we have way of typing literals. Now, can we adapt the same ranking mechanisms we had for phrases for object properties? So take this example: United States President and President of the United States. So these are two literals, and if I want to get the popularity or frequency of these two literals, I only search this part, I'm missing hits for this representation. So it is not the correct way of getting statistics from the knowledge graph. So what we do here is we take the popular entity from the phrase and then use that entity statistics to use in the ranking equation. Take this example for 44th President of the United States. We could map two entities here, President and United States. And then by statistics, United States is the most popular one in DBpedia. So we just use it in our equation. So simply stating how we modify the equations to work here. The same equations, informativeness, popularity, and product of them as the rank score. We just adapt the value part here. For example, informativeness, we get the maximum frequent entity, the most frequent entity, and then use it to map for triples and then count the number of triples we have. So I'm not going into details, but we can come back if we have questions. So this is the modification to the ranking that we do. And we also rank facets that Dr. K.K. Chen's question was like, earlier the phases, the picking of the groups were random, and we take the average scores for each facet, and then we have a ranking mechanism for groups here. So in picking the summary, in the last step here, we go in the order of ranked facets rather than randomly picking them. And then we also do the type computation for feature enrichment. And then we have adapted ranking for TF-IDF based equations. And we evaluated here again, so we measured the summary quality with the extended phases approach, which we call phases E, against railing. We couldn't use the earlier one of the approaches we used in our previous evaluation because it could not use data type properties. So the idea here is we still show we expand the features that we consider for summarization and show that still we are performing better than the existing system in the summary quality. So summary quality and average, the equations are the same as presented earlier. So that's some.
The literals in this case also were taken from the ontology. You say pick the random entity taken from the Wikipedia, the one that you basically tried to match.
Yeah. So what happened here was the 20 entities we have here are taken from our previous gold standard, that was DBpedia version 3.9, and by the time we did this, we used 60 more entities from the newer version at that time, DBpedia 2015 version, and then we make it fair that we are using more recent information.
So how many literals were involved in this case, in that new 61?
I didn't measure them exactly.
No, data type property versus object type property. Do you have a sense?
I have the statistic for the overall graph, not for this entity sample. I didn't measure the exactly what is the proportion. So my guess is at least there were like at least 30% or 40%. Some of them were labeling properties. For example, if you say Barack Obama, name Barack Obama, that property is meant to say it's not about a person, it's a labeling property.
No, but your generic observation was that there were like 1600 data type property while there were only 1100 object types. So data type properties were significantly higher than object type.
Yeah, but then there are...
That's not typical then?
No, we also filter out here the labeling properties and noise. Sometimes there are noise. We are not using automatic way of filtering them out. We manually filtered the labeling properties. For example, let's say surname Obama. We should not be typing them. So our algorithm cannot identify them as labeling properties. So that's one limitation that we have, which will be a contribution if anybody wants to do. We don't automatically identify which are noise, data type properties and labeling properties. In the literature also, it's not proposed yet any approach. I have seen people, what they do is like they manually remove them, and I have seen papers doing them. So this is about our second approach, and this was published in ESWC 2016. So going to the last part, so for the first two parts we were looking at single entity summaries, and now we are looking at can we generate entity summaries for a collection of entities. That means processing more than one entity at a time to get the benefit of relatedness between them. So what we want to do, or what I want to emphasize is, if I take Apple computers and Steve Jobs, and we do try to improve or the quality of importance of features and diversity as we have looked in the first two approaches. But since they generate, for example, summary here independently of Apple computers for Steve Jobs, it won't be able to see matching things to represent for both of them. But what we want to achieve for multiple entity summarization, instead of trying to keep importance and diversity, we want to improve the relatedness of facts we pick for these entities. So this may not be the most appropriate one for, let's say, to show in a Google search, or you are searching or assisting users. For example, there you only summarize one entity at a time. But it could be useful if you are looking at a news article, or you are looking at a document which contains more than one entity, and there is a need that you want to present their summaries, which I show in boxes here, and try to get similarity between the entities and then try to get the context into the user. For example, for Steve Jobs, if it can try to match Apple somehow, even though it's Apple computer, but it says his title belongs to Apple Incorporation, and that may give a connection between Steve Jobs and Apple computers. And also it says his birthplace is California, which California appears here in another entity. But if we are representing them for a single entity, birthplace California may not be the appropriate one to show. There may be more important ones, informative ones to show. But here we are trying to maximize the relatedness between entities.
I'm really interested in the context in which multiple entities are available to you, for which then you can present summarization.
Yeah, for example, this Twitter's campaign. I mean, use cases.
Where you would have the appropriate entities together, and then you.
So this is actual news article, I think taken from Wikinews.
Right. So you are saying that this is an example where you can provide multi-entity summarization.
Yeah.
What others are there? Can you think of, it's like the following: what are the different situations in which I can do advertisement, right? And there is,
Yeah, for example, you are browsing products in let's say Amazon,
uh,
and in your history you have browsed, let's say for example, it could be same type. Here the types can be different, so the computers, people, and then places. But then if you try browsing, let's say Amazon, and then you are trying to buy a computer, let's say you are searching Apple computers and then Microsoft related technology, and then we could try to tell them, okay, these are the related ones between them, and then you may be able to take the decision. Maybe we can, it's application dependent. Maybe we'll improve the relatedness or improve again the diversity between things, so make them so unique between the two.
right. So the point, what are those user activities where user is interacting with the content online, where you have where you can observe relevant entities of interest to the user and then create a summarization, right?
Yeah, let's say in browsing, he was checking on some entities in the past. So that makes, so here we consider the entity collection that appears here. There the entity collection may be the ones that he has looked recently, recent past, maybe 1 hour or 1 day. Or maybe in the tweet context, maybe the past few days or weeks tweets that he has tweeted or he has been engaging with.
We may want to find an example that helps you disambiguate. See, for example, in the search context, right, like a word such as subway might mean transportation or sandwich.
Yeah,
and something of that sort we should probably cook up to make this point clear.
In this type of use case, we may not be successful in developing more disambiguated entity summaries because you always try to make the relatedness between the two.
But in the process, you are going to discount other potential meanings, right? If you have multiple meanings for the same word, then you will say this is not possible and the other one is. So I give you the simple example of subway where it has two meanings, one in transportation context, another one in food context.
Yeah, you mean maybe subway appears here and a subway restaurant here.
Right, versus metro or something.
In that case, it is also an effect of how you identify the entity. So entity linking is not what we are doing here. It's
That's
part
more of a disambiguation problem.
So we assume that entities are already identified. But you can incorporate both of them, but then that is not our focus here.
So what are the situations where you identify 4 entities but then you would get a better result if you ignore one of them and just use the 3 of them, or just use 2 of them? And are there any ideas or thoughts on being able to identify things of higher interest to the human and then focus only on them rather than give things on less important items?
Yeah, so we encountered this. I collaborated with Amir for this. And then when we were looking at results and we were running for test cases, right? Sometimes it's not always the good idea to take all the available types here. Maybe there is a way that we can do the grouping first. Let's say we can adapt our faces grouping here. And then only do the summarization for the specific types. And let's say Apple computers and those may still fall into the same group because they are related. But let's say in this case everything here may fall, but maybe not California or San Jose. There are cases that in a document in the same paragraph maybe you talk about disconnected things, but then here we don't consider those complex processing approaches. If you do some kind of grouping first, it may help to improve the relatedness of related entities.
Hey, here's another example. So let's take Trump. So take a paragraph that talks about his business issues versus his political things. Maybe you can bias your summary based on what the surrounding paragraph is.
Yeah, that is true. That's why I said if let's say the Trump appears in both paragraphs, right? But then we do the grouping. Maybe for the first paragraph, the the latter entities may not be considered to create the summary. So you need maybe a grouping mechanism before coming into summary generation. So only for that specific related entities we apply this approach.
Yeah, the groups may still be the same, but you'll pick a different group in each case.
So in old days of Tali and Semantics, what we will do is to take this paragraph and do automatic classification. So classification in business, sports, politics, whatever, and then focus on only the entities in the that domain, subdomain that you find to be relevant, and hence you have better focus.
Right.
Yeah, there I believe this summary we generate could be way better improved, and also there is extended analysis could be done whether that grouping is needed or you need to relax it. Sometimes totally unrelated entities can be the ones that you want to show the relatedness.
No, basically the point I'm trying to make is that you can probably include this as one paragraph in your future work.
Yeah.
So I don't know, in the slide deck that I had sent you, there is something called semantic browser that we had implemented. There, if we come across the word Apple computer, it will look up the ontology and identify all the other related, entity types that are there, like these. And then in our case, we had BSBQ, blended semantic querying browsing. So you could be querying, getting some results, seeing the semantic annotations, and using that to browse either the knowledge or from the knowledge any of the instances, like the news items related to those knowledge entities in the knowledge base, and then go back from there right into the search if you wanted.
Yeah. So all these extensions can be made. So we also believe that the results we get could be further improved because we are proposing how to maximize relatedness. So if I go to the problem that we want to solve here, so we want to maximize these three optimization objectives we have. So we want to maximize inter-entity importance and diversity, which we already have been considering in our previous two approaches. In addition, we want to do the inter-entity relatedness. So the idea is you get different types of entities. In this case, you can't guarantee that you get all people or all places or all, let's say, movie actors. So there are challenges. So what I want to do here is, like, for each summary I'm just representing, we still want to maximize the importance and diversity within each summary. But we need to consider this many combination of processing, or how to ensure that the first entity you try to pick related for all against all the other three entities. So it is not a simple task that you need to consider all these pairwise comparisons, for example. So in our approach or the problem, we need to maximize three objectives, and then we try to map it to a one profit function. So maximizing these three will also maximize the profit that we want to compute. So we adapt our problem to an existing well-known approach or the problem topic, which we call quadratic multidimensional knapsack problem. The base version of it is quadratic knapsack problem. What it says quadratic is because the profit here is always computed using a pair of features or pair of items. And this is how we formalize it. If feature 1 is selected, this x IA will be 1 or otherwise 0. So final profit determines which features we select based on this pairwise profit computation, and also restricted to the constraint of each knapsack. So idea here is taking the abstract idea that I mentioned earlier. So maximizing the profit should also be done according to the knapsack size. Here the knapsack size is the length of each summary. So that's the restriction we need to keep on mind. And here the ki means each summary length. And in our problem, the weight of each feature we make it uniform, equal to 1. And that effectively makes the summary length is the knapsack size. So briefly looking at and going through how we want to measure the importance of features, we simply use the equations that we have been using in our phases framework. We take the informativeness and popularity of the features and then take that rank score and in trying to maximize the profit, we have coefficient alpha that we need to tune for this application. And what we have to keep in mind here is that in this quadratic profit function, the importance of the features, if you consider the profit matrix, it will be the diagonal. So if the entities are the same and then features are the same, this approach only applies, the importance computation. And next, how we want to measure the relatedness of features. So for this, there are two parts to measure relatedness in our case in entity summarization. First is we want to measure relatedness between properties. What we do here is we do the semantic expansion. We look at word set computation in phases and apply it to the properties of the features and measure the Jaccard coefficient or the similarity. And then for entity relatedness in the feature, the value part, we use a proposed approach called RDF2VEC, which provides you vector representation of entities in knowledge graphs based on their co-appearance in the path. We take their cosine similarity of the two entity vectors, and then we combine them, and then we say this is how we are going to measure the relatedness. So this is how we do the relatedness, and then we use this relatedness first to ensure the diversity in each entity summary, and also the next part is relatedness between entity summaries. For this, if we look at what we are doing here, if features are coming from the same entity and they are different, only applies this processing or computation. That means if features that we compute the profit are coming from the same entity, we want them to be different. So if the features belonging to the same entity have higher relatedness, we make it a negative reduce the profit by multiplying it with the negative coefficient. So it makes our profit go down if we try to select more related things within each entity summary. And also we do modification for the optimization algorithm. We do ensure that we get also improved diversity, which I will explain in that part. And then to maximize relatedness between entity summaries, the large part, if entities are not the same, so features coming from different entities, so we just want to maximize the profit if the relatedness goes high. So we have a positive coefficient, and then multiplying this, higher the relatedness, our overall profit will go higher. And then briefly, I don't intend to spend time on this. We adapt an optimization technique in solving the quadratic multidimensional knapsack problem. So we use GRASP, which is greedy randomized adaptive search procedure. What it does is, because it's an NP-hard problem, what it does is it randomly creates many solutions and try to give you, based on those solutions, the optimal one. So construction phase is where we do the modification to ensure we get further improved diversity. So it randomly selects features which it called candidate features, and it is named as restricted candidate list. If we somehow make sure selecting features for them are not going to be the same coming from the same entity, we are ensuring that the final entity summary is diversified within each entity. So what we do is like we simply filter out if there is relatedness of two features are higher for the same within the same entity, one coming from the one that we want to select into the summary, and others are already selected in the candidate list. So there is this filtering approach we introduced, and this is the evaluation we did. we use two data sets, and I'm not going to explain all the details, so it is lengthy, but I put it here for completeness. We used two data sets and 15 judges, and then we used 850 question instances. So we are measuring this system or the approach using 5 questions, because we believe that it is not fair to give users set of entities and then ask them to create gold standard, because here you have to look at maybe more than 2, 3, 5 entities at a time. Human mind may not be able to process all the related things at once. So we are measuring the effectiveness of the approach using questionnaire, which is the Likert scale. We ask questions whether do you like this summary over the others on the scale 1 to 5. And the interesting thing I want to show here is the second question. We ask the fact that are the entity summaries are diverse, and then there is no statistical evidence to say that our new approach is better than phases, because both of them try to maximize diversity. Even though their mean value is higher, we can't with confidence we can't say our approach, this new one for the multiple entities, are always better than phases on this aspect, which is diversity. But it performs comparably and slightly higher. So that's what the idea that I want to convey, and all the other questions we are performing better, and then there is statistical evidence that to say using questionnaires, the judges think that we try to maximize relations between entities and also try to achieve importance and diversity within entity summaries. And that is a qualitative evaluation. We also try to do quantitative evaluation, which means take an independent knowledge source. Here we took the Wikipedia, and then quantitative evaluation, what we did was like we were measuring how related the facts that we select for each entity summary, and we used two measures, UCA and UMass, and the idea is higher the value for those indices, the system is better. So using that quantitative analysis, it says our approach selects more related things into the entity summaries. So that gives an overview of the final work that we did for multiple entities. So putting all these things together, the different colored points related to different sections of my claim about the thesis. So first part we did for object type properties, and then we do single entity summarization. So these items are marked the same color, so we do conceptually grouping and ranking mechanism. And the second is we introduce typing mechanism for literals, and then lastly we do try to compute more than one entity at a time, maximizing their inter-summary relatedness. So that concludes the approaches that I want to talk on this presentation. And briefly looking at my stay here at Noises, these are the different areas that I have interacted with, and I have fruitful collaborations with. Basically, I started my first internship with Dr. Edward Curry at Insight. At the time it was called Daily, and I liked the way that I got interacted with him, and it showed me to improve my research progress. And also then in 2014 I did an internship at NLM with Olivier Bodenreider, and then last year I did internship with Dr. Hamid Motahari in 2015 at IBM Research, and then there we were able to publish patent is pending, and we already published a paper in World Wide Web. So I had all with my committee members, and also not to forget Gong Cheng, who is an expert in entity summarization. I would say he worked a long time on this area, and then I started collaborating with him and published several papers, and I am thankful for his guidance as well. So some selected publications. So I have publications now in World Wide Web, ESWC and AAAI, and additionally I'm happy that I was part of organizing a workshop series in ESWC conference, along with again Gong Cheng and one of my other collaborators who was already working in entity summarization, who's Andreas Thalhammer from Germany. And pointing out few highlights, I already talked about I have published in good conferences, and I'm thankful again for Edward Curry for giving me for having me there for my first internship, and Olivier Bodenreiter at NLM, and Hamid Motahari in 2015 for the IBM internship. And last but not least, I would like to thank Professor Amit Chet, who's my advisor. I still remember the first day I was trying to come here, and then you were showing me, and Corey was here, and then you were showing me all the labs, and then you asked the one question. I remember, are you going to change your mind talking to your parents? I said, no, I'm going to come. I still remember that. So he was worried that with our culture that we can change our mind not to go, and then I said, no,
Parents are frequently used as a reason why they are doing something or not doing something.
Yeah, so I wanted to do higher studies. I said, no, I want to come. And then I'm thankful for him, all the guidance, and then
all the difficult times I gave you.
Yeah. And at times I wasn't having enough progress, and then I could see I have achieved some of them, and I'm happy that he had patience with me for maybe first 3 years. And then Professor Krishna Prasad Tirunai and I started working after coming here, and he's also my advisor. And I remember the days that we talked about. I will miss those days, because when we are about to submit a paper, last 2-3 days, every evening I will just talk about, and then we're worried, oh, have we done the correct thing, or I need to change things, and then I'll be missing those days. And then he's always a good advisor with technical things that I wanted to do, and then advising me and trying to improve on how well I am technically presenting, or how should I be doing things. And then Professor K.K. Chen here, and then thanks for your insights in being in the committee and then giving comments. And then I took his courses in cloud computing, and then earlier when I first started here, I was going to do PhD on cloud computing, but then it changed over time. And Edward Curry from National University of Ireland, Galway, Ireland, I'm thankful for him again, and then he's a good person and fun guy, and then you see from his picture. And then when I was there, we used to go for pubs sometimes in the evening with his team, and then so that's the work culture there.
I was doing, going to pubs.
Even though I don't drink, I like his attitude. I like the way that he showed me. I wasn't knowing anything much detail in how research things work, so I learned a lot from him. And Professor Gong Cheng, always there to help me, and then we were formalizing things. I published one paper and submitted another one with him. So I always valued his guidance, and then I'm glad that I started collaborating with him. It made an impact on my graduation as well. And Dr. Hamid Motahari, who gave me the opportunity for my last internship to work at IBM, and I get tremendous experience in working in the industry and the research world, and then it helped me in all my job search and then my experience. I could probably say that I filed a patent with IBM and co-authored a paper with him, which I learned many things, even though he always writes in the last minute, and I always awake like 3 a.m. in submitting paper. I remember last time we submitted, I was editing a one item we have 5 minutes to submit. But I still like
But Amit has promised me that next time, he would give this thing a priority and, and give me a time to also look at the things.
Yeah, but you see, he was in a meeting 5 minutes before today, so I don't know why he's so busy.
Come on.
Next time when we have to make the students actually to present the results much earlier to
Yes.
the professors. Yeah.
Okay.
Thank you, Kalpa.
Welcome.
Basically, it was a pleasure having you here, and great to see you basically on your defense day.
Yeah, I'm glad to. Yeah, and then I don't want to forget Dr. Ajit Ranabahu. Ajit Ayya we call, and then he's the first person I started working with, and then he was the bridge between me and Dr. Chet and me coming here. And then I loved working with him, and then because of that, several others ended up staying here, and then at one point, Sri Lankans were the biggest group over Indians here. I think it started with maybe me after him, and then several others came at the same time. And I authored the paper with him, and I'm grateful for his insight, and Dr. Olivier Bodenreiter. I did an internship in 2014, and I learned a lot from him. And lastly, I would mention Dr. Gamini Palivarna, who is my uncle, who always, in my childhood days, talking about higher studies. He did his higher studies. That's when I had the idea that I wanted to do higher studies. So I'm thankful for him. And my colleagues at Noises, I'm thankful for them. So I have two pictures, because first one is my generation, and then Amir was complaining he's not there. I have the second picture, and I'm thankful for my family, my parents and my wife's parents, and then because of their support I was able to come this far. And my family, my wife and my daughter, and then they were maybe the inspiration to me, for me to publish and then finish in this journey. So that's all I have to say, and thank you.
So questions, guys, from the audience? Schools are very quiet. What's that?
Sure. I'm happy to throw one or two in. So Kalpa, thank you very much for your kind words. I'll point out that when we went to the pub, I think I was the only one drinking. Everyone else was on water. So I've got a more general question, Kalpa. It's more about your thoughts. When I look at the pieces of work that you've presented, they're all very interesting in the context of knowledge graphs. And when you look at your thesis statement, a key part of your thesis statement talks about structured data on the web. And I think I'd like your thoughts on how specific are your techniques for web data. And when you think of web data, you have features like it comes from multiple sources, it has a lot of noise, it has a lot of duplication. There's features around the web in terms of, do you trust the sources? There are different authorities on the web. I'm wondering, what are your thoughts about your techniques suitable for web data as opposed to knowledge graphs, which are potentially a different type of data?
The techniques that we presented here are always, specifically we are working with features, and I mean triples. And if there is always a way of extracting sentences or interesting sentences from the content, you can directly apply these approaches. Let's say you extract more than 3-word sentences that we, or 3-phrase sentences that we consider triples, but then you somehow segment them, and you may still be able to apply these techniques. And again, for example, even though the final approach and then the result is for entity summarization, for example, grouping, we adapted an existing technique which works well on document level, and then those will still be working even better if we have semantic enrichment like things that we did. So there won't be a problem in adapting these techniques for general web content, but my guess is they will work even better if you have the structured way of presenting those in some way. So they don't need to be in triples or RDF or specific way. So that's why I didn't say it is for RDF. So if you have different ways of representing the same knowledge, still it will work.
Okay, so in terms of limitations of your work, what do you think the key limitations are?
Limitation is specifically for the approaches that I presented. For typing, those could be further improved, as I said. So the automatic way of deciding which are important features, maybe using some machine learning techniques, and the way that we group things, we didn't extensively check how good they are. They could be adapted in a standalone contribution. Let's say grouping triples in more abstract way, or semantic-based grouping, you could name them. So even though we were satisfied with the quality of groups that we get, they could further be improved using the way that you extract types or expand using a lexical data set. We use WordNet. Maybe hypernyms, maybe you get more other ontologies, try to align them and then take their input. And finally, on the multiple entity summarization approach, we believe still there is, even though we were better in some sense, the results that we get needs to be further improved. I was talking with Amir some time back. So we wanted to take the input from the text input, maybe using word-to-vec model along with the RDF-to-vec model, or actual text phrases in the token level, and then make them compute some relatedness along with the graph level or knowledge graph level relatedness. So in all, I would say the approaches that I presented in this area, they were among the few first ones. So Gong started working on entity summarization in RDF in early 2011, and then we are in 2015. We were in 2015 when I first published in AAAI. So we introduced the phases approach. So we haven't seen much systems or approaches yet. So I believe even my approach and all the existing approaches could further be improved continuously to achieve higher results. And one other approach is for phases and all the others that I presented, taking the personality aspect into consideration, mining query logs or user browsing history or any kind of personalized context. So there are many ways that I could say these things could be improved or even make some other work.
Sure, thank you.
Yeah, you're welcome.
Gong?
Yeah, I have two somewhat specific questions. The first is, can you turn to slide 49? Yeah. So I just found that for intra-entity diversity and intra-entity relatedness, they are actually based on the same relatedness measure, that is R, right?
Yeah.
So I'm wondering, would it be better to use different measures for, one measure for intra-entity diversity and some other relatedness measure for intra-entity relatedness? Is it possible that some better results can be achieved? So is such a measure task dependent, maybe, or not? So anyway, so the question is, how can we choose such a measure?
Because I don't see the difference in the way that we want to compute the profit. They are always between relatedness. So we lower the relatedness, we get the diversity. So there is that function between relatedness and diversity. So that's why we did not encounter, or we did not think there was need to have two different representation or measuring relatedness, but then it is possible. But I'm not sure what kind of proposal that I want to make to, let's say we keep this for, let's say, inter-entity relatedness, and then what else or what better way of doing it for intra-entity diversity or reducing the relatedness. Because effectively, my thought is if you minimize the relatedness, then I would get diverse facts. So I think it is possible, but I'm not sure what to do right now or what other measures that I could be using.
Okay, and there's another minor question. So in your first work, you did semantic expansion by using WordNet, right?
Yeah.
And I just found that because you introduce a lot of hyponyms by using WordNet, so it is possible that many high-level abstract words are introduced. So some of them are actually just noise, maybe. So is there any side effects? Did you observe any side effects?
For example, before getting the WordNet hypernyms, we removed the most top-level ontology classes. For example, owl thing and maybe person and then that level, because they are so generic. So it could be noise. So we don't know yet what level we should be getting at these hypernyms. So even the WordNet has many sin sets or many different meanings. So we don't restrict or we don't filter any of those sin sets or representation. So that part could be further improved. So as you said, it could be noise sometimes or most of the time, it's true. But then how it works, my guess is, even though it has these overlapping things, so then the similar things anyway will have those overlapping items with them, but then things that make them distinct or want to put them together will have different items to each other as well. So I don't think it will make a huge difference if we do a complex processing and remove all those same overlapping items or higher level abstract items, but it could improve the final grouping results and maybe slightly the summary quality.
Mm-hmm. Okay, and my last question is about ranking. So basically, you use some TF-IDF-based ranking, right? You call it intuitively rank, and in the IR community, there have been a lot of learning-based ranking approach. Have you considered using any learning to rank method to improve?
No, you mean getting the user feedback?
No. I mean, okay, so maybe you can turn to its slide 21, maybe. Yeah. So the ranking is based on a TF-IDF-like metric, right?
Yeah.
It's based on informativeness, popularity, these two features. I'm wondering if there are any other features that may also work. For that purpose, I mean, maybe you can define some other features and to use learning to rank to weight different features and to generate some better ranking method. Is it possible to do that, or if not, what would be the difficulty there?
Yeah, it is.
Because
yeah, it is possible to add more components to this. For example, we could always use the page rank that you use for authority for entity part, and then always incorporate it with popularity or the frequency. We could always add more things. As I said, we could improve more on this. I'm not saying this is the most appropriate and then final ranking score. So we can add or multiply by other components. But then for this simple equation, with my experiments, adding let's say, coefficients for each term did not make any sense or didn't make any difference. But then adding more parts to this to improve different ways that we think ranking should be happening, so we could do that. For example, taking input from graph-based authority ranking or popularity and try to incorporate them here. So it is possible, and then it will also get an effect like overall agreement on ranking rather than just the frequency. So I believe we can add more things here on top of this.
So one comment about learning to rank. So for them, more like a supervisor learning, you need like a label the training data. And your approach, it seems like unsupervised. Right. So that's the difference.
I think I just want to make a comment. So second question Gong asked was really interesting for me and important. We kind of use the tools we have at hand, and so somebody's put all this work into developing WordNet, and that sounds reasonably relevant. But my intuition tells me that that's really it's okay. I mean, for experiments and for the current state of the art is there, but that's just if you think about how humans would apply relevant knowledge or how humans would extend, let's say you are given a term, what other terms you will think about. The kind of, WordNet is too domain independent, too broad based, too generic. And most of the time it kind of will increase recall with small, with too high a drop in precision. When the cost of precision, drop will be, in my view, will be too high for the recall you might, increase per se, and then you will go too far off from your original purpose, what you are looking for. So, ideally, it would be good if there is more of a domain-specific set of, dictionary that you use to expand whatever you want, wherever you want something. I mean, if you are doing some very generic search on very high level, that's fine. But if you are looking at, let's say, search on business news, you're looking search on stocks, you're using search on biomedical molecule. There is all this, what WordNet kind of resource give you is too irrelevant and broad and fuzzy, and takes you too much away from what you're really looking for. So usually I would be very careful when you say, okay, I'm doing this. It's okay for a paper, but in reality I might have significant doubts. Anyway. Amit?
Yep. Thank you first, the committee and then Kalpa specifically for the great presentation and work. So one observation and both questions that are in mind related to the last piece of work that we presented on basically multi-entity summarization. So the three dimensions that you put there, importance, relatedness, and diversity, specifically I was wondering, how relatedness now is applicable here comparing to the grouping that you did earlier, and why you did not bring in and use the notion of grouping and clustering that you had earlier, and rather try to introduce a new measure of the standalone as relatedness. And, taking back one step back to what similar to what also Amit mentioned, basically looking at it from a human point of view, when you are trying to, the purpose of summarization is to get as much of the information that you want about an entity in a very concise manner as much as possible. So I'm wondering how relatedness, first of all, helps if there are multiple entities that are related to each other in a summary, how that it would help with the objective of including as much as possible information in a concise manner, if you will. So that's my first question.
Okay, so we were evaluating in picking related features for each entity summary for the collection, and then our evaluation using questionnaires were focused on evaluating that aspect as well as the other two, importance and diversity. So we were evaluating whether users are seeing related things that we pick for the entity summaries, but there is always drawback that in this evaluation that I have seen when they were doing, because for the machine it can identify the related facts by processing many more information, much more information. But for a human, if that person is not knowing that they are related using some previous experience or having background knowledge, he won't see the related facts being selected. But for the computer, it is fair to select those two features because there is a link. There are many links in the knowledge graph between them, and then the computer sees they are related. So, but the humans may not see that relatedness. So, but to some extent, we think this is the best maybe we could do in evaluating. The other question that you had, why we didn't use the grouping that we used in phases, because now the problem becomes when you want to select relatedness features between a collection of entities, you always end up, like I showed in the animation, that there are many pairwise computations necessary. So then making this early grouping for each entity makes it maybe impossible to devise an approach for this relatedness based computation. So that's why we ended up having incorporated other techniques like modifying the candidate list that we are selecting to improve the diversity, and also penalizing the profit if more related things are selected for the same entity. So there is difficulty that running or making groups for each entity. Now when we have groups for each entity, now there are many more sets to be computed on top of the entity-wise comparison. So that was not the ideal case to do, but then it could be worthwhile idea to think how that approach could be integrated here. But then I don't see a straightaway process to do this.
Okay. So the second point, I'm wondering if you, apart from your experiment that you needed to be in a limited setting and users to be labeling the same set that you are also evaluating on the machine side, did you apply your approach on a larger data set, let's say on the whole Wikipedia, and try to summarize it and then get a summarized entity related to any random entity that you may find in any of the public ontologies? And any experience with that large scale in terms of performance, in terms of evaluation of the expected for that specific entity? Maybe not evaluation, but at least large scale deployment of your system.
We didn't. We actually use all the data like the graph for Wikipedia, and we are not processing only part of Wikipedia, but we are processing only facts related to the entities that we are interested in processing. So in that sense, we are using the whole Wikipedia. So if you want to extend it, only way that we are doing it, like we include many more entities or extending the gold standard or the number of entities that we want to compare. So that means extending the evaluation set. So we are actually using the whole graph for processing.
You know where I'm going with that. Coming back also to what Amit mentioned from a practical point of view. When you look at it from a system perspective, if you are reading news, the example that you gave, and then you want to extract all the related and summarized set of features or entities, features related to an entity that you see there. Did you think about on the fly going and basically computing these, or having an offline database of pre-computed summaries? Which ones they are, and if the pre-computed, how much complexity, time complexity that your approach has versus the online one? Can the online approach scale? This sort of questions.
We can always compute online the typing approach except the last part, comparison of focus term against all the ontology classes. So it takes a lot of time. It computes all the pairwise similarities. So for that only we have to make it offline, or we can make an index offline and make it available. But the other thing is, I would like to mention, even though we compute types, there is no formal way of presenting them in actual data set. So it could be some work that somebody would like to propose or work on. So we can always type things for entities, for ontology classes, assigning to entities, but then not for literal. So there is no formal semantics in RDF in doing that, and it may contradict the existing standards. So for now we just compute them and then make them available for application processing. It's not in the actual data set. We can't include it in the actual data set yet.
Okay, thank you.